Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Today we're at Maple School, home of the Mustangs, and we're here to Well, good afternoon and welcome to Do the Math. I'm Michael, and in studio with us we have Tina. And Tina, if somebody needed to get in contact with us, what would they need to do?
For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. Now, did you know that we were celebrating our 20th anniversary this year?
No, I did not.
That's a pretty big thing, don't you think? It is. We're pretty excited about it. We have a lot of people coming in during the entire season that have been part of Do the Math over the last 20 years. And they've been part of the show for a long time. And some have started with us and then moved on to other things, and some are pretty recent. And you are like the newest person that could be on the show, aren't you?
Yeah,
Like, when did you find out you were going to be on today's program?
like 10 minutes ago.
Yeah, just a little while ago, right? It's 4 o'clock, and you probably found out at like 3 o'clock that you were going to be on the show today, right?
Like 3:45.
3, 4, whoa, even longer. Whoa. So you ready? All right, good. So first of all, before we get started, where do you go to school and what grade are you in?
I go to school at Quailwood Elementary, and I'm in 5th grade.
How is 5th grade?
Good.
What's so good about it?
That I get brain breaks every like 10 minutes.
What? Brain breaks?
Mm-hmm.
Tell me about this.
It's like a game that we play in the middle of class when when our brains get too bundled up in a whole bunch of different stuff. Like we play a game like Silent Speedball or something.
So you just take like a little 10-minute break?
Yeah.
And you do some sort of an activity or something like that. So how do you know when it's time for that, or is it the same time always?
It's like different times. Like after recess, we'll wait like 20 minutes and then we'll take one. And during math, we take some.
Do you like these breaks?
Yeah.
Would you like to have more of them or less of them, or are they
More.
pretty good? More of them?
Mm-hmm.
Well, how do you think you're going to get more of them? What do you think you would have to do to get more brain breaks?
To fill my brain up more.
All right, see, and that's what we're going to help you do today, all right? Did you know that every time you struggle with a math problem, your brain grows? Did you know that?
No.
You're in 5th grade. Imagine if the only stuff you knew was the stuff you knew in 1st grade. Do you think that'd be very much fun?
No.
Probably not, right? You want to learn more,
Yeah.
right? So that's what and every time you struggle, you learn more. Your brain actually physically grows when you struggle. There are more connections being made. So are you ready for another problem?
Yep.
All right, let's take a look, because we've got your homework right here. So why don't you head on over to the board and you can start working it out as we look at it together. So Andrew can frame 9 pictures every day. He has an order for 108. How many days will it take him to complete the order? So he has 108 photos. All right, so you think you need to write that anywhere? Well, yeah, just make sure your pen touches the board, nothing else. All right, here's what I'm going to have you do, Cristina. So circle that and erase it for me. You know how to do that, right? There you go. Do me a favor and just write it bigger. But yeah, I think your sleeve is touching the board at the same time. There you go. Perfect. That's better. All right, so there are 108 pictures, and he can frame 9 of them every day. So explain to me what you're doing.
Division.
All right, so how do you know where to put those numbers?
You do the house and you put the first, or the smaller. Okay, how many he has, you put in the house, and then how many.
You're doing every day?
Yeah.
Okay, so explain to me how you want to start it.
I have to see how many would go in from, how many groups can I make of 9 can go one, but I can't do that. So then I put an X at the top of 1.
Good.
And then how many times can you put it into 10? You can do that once. And then you write 9. And then you subtract it. And that's 1. And then you bring down the 8. And then that's 18. And then how many times can it go into 18? Twice. And then that's 18. And then you subtract that. And that's 0. So then your answer is 12.
So my answer is 12. It's 12 what? Let's take a look at the problem again. Andrew can frame 9 every day. He has 108. How many days will it take him to complete the order? So the answer is?
12 days.
There you go, 12 days. Don't forget the label, right? Because if you don't label it, they'll go 12 what? 12 minutes? 12 years?
Yeah.
Right? That would seem kind of ridiculous, wouldn't it? All right, nicely done. You can go ahead and erase the board right there. 636-4357 is the phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. And today, I believe it is the 28th today of September, we are giving away Kern County Fair tickets. So we'll do that today and tomorrow. So if you phone into the program, we do one of your math problems on TV, you will get yourself a free ticket to the Kern County Fair. Not a bad deal right there. All right. Time now for today's Math in the News. All right, today's Math in the News, we are fortunate enough once again to have somebody in studio with us. This is Iman, and Iman, you are part of the Ford Dimension, correct?
Yes.
First of all, before we start that, where do you go to school and what year are you in?
I go to Bakersfield Christian High School, and I'm currently a senior right now.
Okay. And so let's start talking a little bit about the Ford Dimension. What is, for students that have no idea, what is it?
Well, Ford Dimension is basically a program that all high schools in Kern County have the ability to partake in. And so once there's a whole interview process, an entire application, and so once you get in, you have the opportunity to work with students from all over Bakersfield, and you get to unite for one common goal and put that into a project to help Bakersfield. And it's like kind of a little competition within the program, but it's good. It gives back to the community, and you're able just to participate and work with others and focus on working with people from completely different schools that you'd never would maybe talk to.
Right. So it's open to high school students in Kern County.
Mm-hmm. Yes.
So is it all high school students, or do you have to be a certain year?
The application opens once you're in your junior year, and the program takes part once you're a senior, and that just happens over that course of that year.
Okay, so you're a junior. Last year you heard about this.
Yes.
And so can anybody kind of apply, or is it kind of you need to talk to a counselor or a teacher recommendation? How does that work?
Well, the counselors communicate it to the students, and they sent out a mass email because we're all in the pandemic, so everything was virtual. So
Okay.
They sent out this email with a flyer. I think there was a specific GPA requirement, and then you just work on your application, and they review it, and then there's an interview, and then a social interview, and then it just progresses, and then you get in, or sadly.
I understand. So how was the application process for you?
Well, I was kind of very nervous because the application process asked a lot about myself, and it kind of should be easy to talk about yourself, but I do a lot. Sometimes things are not needed to mention, so I just was focusing on what I do and what I find important, and that was really helpful for understanding what I like and what I don't like, and it was nice to know what I like to put that on paper, because it's good to understand yourself for what you want to do with your future and stuff.
Right. So you obviously have to be a good student as far as grades, your GPA.
Mm-hmm.
What kinds of other activities at school or outside of school are you involved in?
Well, I'm part of the debate team. I like to do this debate called extemporaneous speaking, and that's just when they give you a prompt and you have 20 minutes to prep a 7-minute speech. So I'm part of a debate, and that's my favorite type of speaking to do. And I'm also part of the tennis team. I've been playing tennis since I was a freshman, and it's really fun, but the air quality is making it a bit iffy. But,
Right.
And I also volunteer with the Red Cross.
Oh, good. So you've gotten yourself into a lot of activities, some with school and some out of school, and I think that's important also. So since you started the Fourth Dimension, and obviously you did well enough during your interview to move on, and you're part of this, what are some of the things that you, like how many people are in your group, and where are they from?
I have 7 people in my group. I have 1 person from Liberty, 1 person from West, 1 person from Ridgeview, 1 person from Independence, 1 person from Highland, and 1 person from Foothill. And so like there's a lot of people that I had never even met. And so it was really cool just to go talk to people who go to different schools, talk about how their schools run. And like I just probably would have never met these people if I hadn't done the program. And that's probably my favorite part about it, just meeting new people that I probably.
Right, and that's going to be important as you continue going through life, whether you go to school after this or if you go right into the workforce or whatever your plan is, to be able to network and meet people and be comfortable doing that.
Yeah.
So you guys are all from different high schools, and correct me if I'm wrong, but when you're in Fourth Dimension, you're together to do some sort of a project to help the community.
Yes.
So have you guys come up with something, and if not, how is that process going for you right now?
Well, right now we're in the process of brainstorming, and so we have like 2 main ideas that we've come up with. We have one, basically with the pandemic, there was a lot of like emphasis on social media. You know, kids really didn't have anything to do but like stay home and go on their phone. And so like we noticed that now there's like kind of a dependence on like social media and technology. And so we kind of want to have a little regression and go back to like just being outside and just like giving back to the community. And like there's just so much that people do on their phone nowadays, and they're so connected to it. They have it when they go home. It's something that follows them 24/7. And so we want to like give back to the community, give them options outside of their phone, such as going outside, planting trees, and just having fun with simple nature. And then another idea that we were thinking of is something with the Beale Library and just focusing on giving back to books. We just want to find new activities for kids to do because they became so like dependent on their phones. But we haven't finalized an idea yet.
Okay. Do you think one, like when you guys are discussing it, do you think there's one that you're leaning towards because it might be something that you're actually able to do easier? Like it's going to be more possible to get this one completed?
I think, yeah, we definitely lean more towards the nature idea just because like we all have a backyard. We all have something accessible to us, and that's just really easy to implement throughout town.
Okay, and for people watching and they're like, all right, you got a bunch of high school kids getting together doing a community project. You obviously have adults that are guiding you and advising you. So what does that person do, and how long have you met with them? And I know it's pretty early in the year, but.
Well, we just met our advisors last week, and just based off one meeting, they were so incredibly helpful. They were so the big emphasis with Fourth Dimension project is that you want to have a lasting impact. And so that's what we were kind of struggling to find. And so they were telling us about specific certifications that we could get once we do this a specific activity with trees. And like we would never have known about that. Like where the state of California will recognize our project and like Bakersfield will receive a specific like certificate. We didn't know about that. So they're able to like give us connections to people we would never even talk to, like a city council member, to help get our event or whatever our project is, like exposure and just ideas that we like don't see it, because we're also just like high school kids at the end of the day. So they help like broaden our perspective.
Yeah, and you're busy.
Yeah.
So Fourth Dimension is a big thing, and it's been going on for a couple of decades.
Yeah.
I think. I'm not sure exactly how long. Katie, how long is like
47
when?
years.
47 years. So I was right with decades. So I didn't want to try to. So there's another part, and I think they're like parallel programs, but Dream Builders. Can you tell us a little bit about that?
Well, Dream Builders is the project with all of the high school students. So that involves every high school student. There's 33 of us this year from every high school in the Kern County High School District, and that's where we work on the project.
Okay. And so is that a different process?
So Fourth Dimension, it is just separate from the Dream Builders in the fact that we just are the representatives of the Ford dealership, in a sense. But we all participate under the Dream Builders project, and we work together there. And that's where we all work at.
Okay. And if somebody wanted to find out about Fourth Dimension and Dream Builders and these projects, and they're a junior this year, at the beginning of this year, do they go to their counselors and kind of find out about this, or?
Yes, they can go to their counselors, and there's also the website they have in their Instagram where they post like updates, and their website has a whole part about how to apply, and it's just for dreambuilders.com, I think, but
Okay.
don't quote me on that. And then the Instagram is just for Dream Builders.
Good. And you obviously are busy, a senior this year.
Mm-hmm.
What are your plans for this time next year?
Well, right now I'm in the process of applying to college, and so hopefully next year I'll be in college and I'll be studying finance and data science, and just studying and just, yeah.
And that, I can tell you right now, data science is, I don't think students are aware of how important that is, okay? Because there is so much data
Yeah.
right now. I mean, there's probably more data that we've gotten in our world in the last year than we've received in the last 100 years. There's just so much. So is there an avenue that you're kind of looking at, or you just want to get into that field first and then see
I think I just
happening?
want to get into that field first just to see what I can do with it, because there's so many different avenues you can take with it. You can go down like the financial pathway, or like get an MBA or go to law school. So I just think I want to like experiment it and just try it out and like practice it and see how I can implement it in like everyday life.
Good. Well, you know what? You are in your last year of high school. You obviously have taken quite a few math courses, and this is due to math. So was there any math course that you remember during high school that you particularly liked, or remember something about it that you've been able to apply more than something else?
I think my AP statistics class was probably my favorite. That was like one of the first classes that I actually saw like the applicability, because a lot, like we don't realize how much stats is in our life. Like with like charts they put on the news, a lot of it is not actually like accurately presented, and so like I got to see that whole like understanding of that, and like just like everything around us is like stats. Like it's really weird to see.
That's why I'm saying there's been so much stuff put out there.
And like, yeah, it's
And
just,
you can make it look whatever way you want it to look.
yes, no, and like you think math is like something really just consistent and like you can't mess with it, but math can be manipulated.
Anything can be. All right. Well, Iman, it's certainly been a pleasure meeting you. All the success to you and the rest of your group with the 4Dimension and Dream Builders and everything that goes involved with that. And I know you're going to make some lifelong friends from this, because we've had other students on, and they still communicate with people they did their projects with during high school. So,
Thank you so much for having me.
thank you for coming in. 636-4357 is the phone number. That is today's Math in the News. And we have Tina, a 5th grade student from Quailwood Elementary, in studio with us, and we'll be back with more right after this.
Hey everybody, it's the language of mathematics. We got to know how these words function in a world of numbers. Today's word is mean. Grr, like this big old mad baby here, and this mean guy, and there's even animals that look kind of mean. And of course, this is what we think about when we hear the word mean, but that's not really what we're talking about in math, right? Apparently, even this girl here, Taylor Swift, has some kind of song about being mean. But in English, what we're talking about being mean is usually being angry, or what does that mean? What's the definition of that? Or what did you mean by that, right? Or what's your intention there? What did you intend to do? In math, however, we're going to talk a little bit about a different definition, and that definition is the average, and that usually has to do with a set of numbers. So in statistics, when you're talking about lots of different numbers, you're talking about the average, which is one of the means of central tendency. Even this guy Justin Bieber here has some kind of song called What Do You Mean? Mean is everywhere. However, again, we want to talk a little bit about the average here. So let's take a look. The definition of the mean in math: the total of the numbers divided by how many numbers there are. Here's a real quick example for you, okay? The mean of 5 and 9 is 7. How do you get that? 5 plus 9 is 14. Then there are two numbers, divide by 2, and you can see right there, that's how you do it, right? 14 divided by 2 is 7. Even Kanye says, what do you mean? What are you talking about? Okay, well, here's how it goes. Look at this example here. Find the mean of these numbers. Now, here's a really cool thing about the mean. There are a couple other measures of central tendency, okay? What I mean by that is mean, median, mode, and usually you have to put those numbers in order. However, with the mean, you do not have to put them in order from least to greatest. That's kind of nice. You can just add them up right just as you see them. So we see here that we have 5 plus 6 plus 8 plus 2 plus 4. That total is 25. Count up how many numbers we have. There are 5 numbers in the set, so that number is going to be used to divide by. 25 divided by 5 is 5. The mean of these 5 numbers is 5. Example number 2, let's see how we do on this one. Aha, we're getting it now. We got the thumbs up. Example number 2, how about Bakersfield? This is a wonderful example because we can always relate to this. The mean temperature in Bakersfield, we want to find that, where the temperatures on the 7 days were negative 32? No. 101, 105, 106, 102, 98, 95, and 97. So all you got to do in this example, add those numbers up, and I'll go ahead and do it for you. 101, 105, 106, a couple days in the hundreds. Oh, we got a cooling trend here. Anyway, the total of those 7 numbers is 704. There are 7 elements in that set. So you're going to divide the total number by 7. Now, I wanted to make sure that you saw this example as well, because the mean doesn't always have to be an even number. It knows that it can have a decimal in it. And in this example here, we ended up with a big long decimal, 100.57143. And if you told someone it was 100.57143 degrees outside, they'd probably look at you a little strange. So we did a little rounding here, approximately 100.6 degrees. So the mean is the average. Here's Steph going, when are we going to use this? What are you going to do with this? Well, I've given you a couple examples. Temperature is one of them. A guy like this is really concerned about his average, about the mean number of points he scores, or about the mean number of rebounds, or even in baseball, the baseball batting average. All kinds of things in sports have to do with averages. Prices. Economists talk about average prices in a society. Maybe you want to know your average speed on a trip to get your gas mileage. And all kinds of other statistics you might see either in a newspaper or on a news program. In the community, the average height, the average weight, the average education, the average income level of any particular community, that is where you might find mean. So in the world of mathematics, mean means average.
And that is one of our new features this year, the language of mathematics, because you've heard of the word mean before, right? And you know it's like, well, it's kind of mean to talk to somebody like that. And have you ever heard of it like that, where the mean is the average of the numbers? Well, see, so you learned a little something right there, because I know in 5th grade, and definitely in 6th grade, you'll be doing the mean of numbers, which is the average of some numbers, all right? So anyway, that is one of our new features this year, the language of mathematics. April is in studio with us, and April, we've got a phone call from Emma at Warren Junior High. Emma, how are you this afternoon? Hello, Emma. And Emma, are you there? I have every confidence in Emma that she's there. Sounds like you're there, Emma.
Yes, I am.
Oh, good. So are you in 7th or 8th grade?
I'm in 7th.
All right. As soon as you're ready, go ahead and read the math problem to us.
Okay, so the first problem is -9 times -6.
Okay, so Emma, you have -9 times -6. You're multiplying integers, right?
Yes.
Okay, and so what do you know about multiplying negative integers?
Last year we went over this, but it was hard to understand what she was like trying to explain. So so far in math we've only learned that like we've only gone over adding and subtracting, and so this is kind of just like all new. So we've just been kind of going over it, but not like.
Okay, so I'm going to multiply these two integers, and I'm going to multiply. Let's think of them in their absolute value, and so let's multiply 9 times 6. So what's 9 times 6?
54.
54. And there are rules when you multiply integers. So if you multiply a positive number times a positive number, then your product will be positive. If you multiply a negative number times a positive number, then your product is going to be negative. When you multiply a negative number times a negative number, then your product will be positive. So if you follow the rules of the signs to the numbers, whether they be negative or positive, which product will we have? A positive product or a negative product if I multiply -9 times -6?
A positive.
So then it's going to be positive 54.
Are you positive about that, Emma?
Yes, I am.
All right. Do you have another problem like that you want to work out?
This one is a little bit different, but it's negative 3 times 6.
All right. So
Say that
maybe read
again.
it one more time.
Negative 3 times 6.
Does it look in parentheses or is it with a dot? So this is another way that you can write multiplication.
Okay.
Okay, so I'm finding the product, right?
Yes.
So if I'm multiplying negative 3 times negative 6, I can think of them in their absolute value, and I can multiply 3 times 6. So what is 3 times 6?
18.
18. And now if I look here, positive times positive is positive. A negative times a positive is a negative product. And a negative product times a negative product is, a negative times a negative is a positive product. So if I have negative 3 times 6, my product is going to be negative 18 or positive 18?
Negative 18.
Great job.
All right. Well, hopefully that helps you out a little bit, Emma. And do remember, if you need some more help, we do have phone tutors available until 5:30. But for phoning in this afternoon, you've got yourself a ticket to the Kern County Fair. So congratulations on that. Hopefully you have an opportunity to head out to the fair. And I know they open back up again tomorrow because they did close today to do some deep cleaning throughout the fair and things like that. So they will be open until Sunday evening, I do believe. So we'll get you that ticket and hopefully you have some fun out there. 636-4357 is the phone number. Don't forget, we are all over social media. We've got some associate producers and they take care of that thing like you wouldn't believe. Facebook, Instagram, Twitter, and YouTube. There are so many things going on. I can't even keep up with it all, but they certainly do. So if you want to find out some more things behind the scenes with Do the Math, as we celebrate our 20th year this year, that's the place to go. In studio with us, we have Tina. And Tina, why don't you come on over? You and April are going to go ahead and get started with your next problem. So let's take a look at it together. Madeline can type 3 pages in 1 hour. How many hours will it take her to type a report that's 123 pages long? So, Tina, go ahead, write down any information you think you need to know, and then you explain to April what you need to do. All right? So you can do 123 pages, and you can do 3 pages every hour.
So why are you setting the problem up like that, Madeline?
That's how I do division with a house, is what I call that. And then you divide it.
Okay, so let's go ahead and divide. Talk to me about how to divide.
First, you have to see if you can put 3 into 1, or first you have to see if 3 can go into 1, which it can't, so then you put an X on top.
Okay.
And you see if it can go into 12, and it can go into 12 4 times.
So 3 can go into 12 4 times?
Yeah.
Okay.
And then you put the answer to that problem right down here, and that's 12.
So 3 times 4 is 12.
Yeah, and then you subtract, and that's 0. And then you bring down the 3. And then how many times can 3 go into 3? You can go into that once.
And what does that 41 represent?
The answer.
What does the answer represent?
41 hours for the report.
Okay, so if it's 3 pages in 1 hour, how long will it take in 123 pages? It's going to take
41 hours.
41 hours.
There you go.
Nice.
Nicely done. Well, for some great work this afternoon so far, Tina. You've got yourself a meal courtesy of our friends at the Broken Yolk Cafe. So congratulations on that. Now, Tina, have you ever been to the Broken Yolk Cafe?
Yeah, I go there every Sunday.
Oh, wow. That's awesome. I wish I could go every Sunday. They got some good food over there. That's a nice spot right there. I'll tell you, I'll go, see me on some Sunday over there. Anyway, we had an opportunity to go out to some local schools in Kern County, and let's take a look at today's In Your Class. Well, today we're at Maple School, and I can see home of the Mustangs, and we're going to do a couple of math activities. You girls ready?
Yeah.
All right. So what I'd like you to do is select a number between 1 and 8, and that'll be the activity that we do first.
Okay. 5.
5? All right, let me find 5. An excellent activity, I might say you have chosen there. So, do me a favor, pass out a piece of paper to everybody. And I'm going to have you work in 2 different groups. Okay, so we're going to do one together right now, just so that you get the idea of what we're going to do. And then I'm going to put you in 2 groups, kind of like going against each other. Make sense? All right. So, what we're going to do is I'm going to select a number, and I want you to write it at the top of your paper. All right? And I'll go ahead and I'll do it also. All right? Well, actually, you're in 6th grade, right? All right. Let's go ahead and put a 6 at the top of the paper. We're going to do a little vocabulary. If I say I want the sum of some numbers, does anybody know what that means?
The sum.
The sum. I want the sum. What do I have to do?
Figure it out.
We have to figure it out, but what am I going to do? Like, what operation? If I want the sum of a bunch of numbers.
Addition?
There you go, addition, right? So the sum is what we have to do. So we're only going to be adding numbers, okay? So what I want you to do is I want you to write down as many ways as you can think of that you can add 2 numbers to get to 6. Don't start yet. I know you guys are all ready, but we're going to put a timer on this. All right? So, how much time do you think you need?
I don't know.
You don't know. How about I give you 15 seconds? You think you can come up with a lot of ways to add up to 6? Go. All right, so does count how many different ways you have?
3.
Does anybody have only one way? So you were all able to come up with more than one way to get to 6, right? So tell me one of your ways. And if you have the same one, just mark it off.
4 plus 2.
4 plus 2. And if you had 2 plus 4, it's the same thing, okay?
Oh, 1 plus 5.
1 plus 5. I had that also. What do you have?
3 plus 3.
3 plus 3? Excellent. I didn't even have that one. Oh, I was writing too quick. I had 3 plus 4.
0 plus 6.
0 plus 6? Excellent. Did you have anything different?
Well, I just flipped them. That's all I did.
Okay. Did anybody use anything that hasn't been said yet? Like, did anybody have something on their paper and we didn't say it yet? How about this? Did anybody try using negative numbers to get to 6? Now, you've all worked with negative numbers before, right? Okay, see, if I had -7 or -1 plus 7, that would give me the 6, wouldn't it? All right? So that's kind of how that goes, all right? So here's what I want you to do. Select another number between 0 and 10.
0 and 10, 7.
7, all right. Go ahead, 7. Are you ladies ready for the timer? I'm going to give you 15 seconds. Remember, you can do negatives if you want as well. Go. All the different ways you can come up with 7. All right, there you go. There's 15 seconds. 15 seconds goes by pretty quick, doesn't it? All right. So, what was one way you came up with?
1 plus 6.
1 plus 6. Did anybody use a negative number? What do you have?
-1 plus 6.
-1 plus 6. Now think about what that's going to be. You're at -1, and you're going to add 6. So if we are at -1 and we add, there you go. All right, so just to get you to thinking. But that's just a simple little activity, and it's kind of like fact families, right? So we're trying to get to this one number. There are a lot of different ways we can get there. But that's one of the activities we're doing with the 6th and 7th graders at Maple School. Well, we had a lot of fun out there at Maple Elementary School. A beautiful facility as well, some great kids to work with, and had a lot of fun doing those math activities. We do have phone tutors available until 5:30 this afternoon, as we do most Tuesdays and Wednesdays throughout the regular school year. If you are new to the program, Do the Math, a lot of different ways to get a hold of us. We've got a toll-free number. We have an email. You can always stream and watch the program online, and we're all over social media. Those things will come up periodically throughout the program. You'll see at the bottom of your screen. But important right now, we have Naomi. Naomi, you're a student at Bill L. Williams, correct?
Yes.
And what grade are you in?
6.
All right, as soon as you're ready, let's hear the math problem that you're working on.
Okay, I am working. Okay, it is 0.2% of 6,500.
So 0.2% of 6,500, was that correct?
Yes.
All right. I think April's going to be all set to help you out with that.
Okay, Naomi, so what do we know about, what are we looking for?
Well, the percent.
Yeah, we're looking for a percent. How much percent are we looking for?
2.
2
Point
tenths. It's 2 tenths, right? Because you said 0.2%, right?
Yes.
So 0.2% of 6,500. So which way do you know how to find the percent of a larger number?
I don't know.
Okay, so I can say 2 tenths times, so I can multiply that by 6,500 in order to get the percent. Okay. Are you ready? So then
Yes.
I'm just going to multiply 2 tenths times 6,500, and 2 times 0 is 0. 2 times 5 is 10, and I'm going to carry my 1 over, and 2 times 6 is 12 plus 1, which is 13. And if I'm looking for 2 tenths, I've got a decimal here, so I have to also cover that decimal in my answer. Doesn't seem small enough. Is it small enough? Mr. Cooper?
You want to check that? So let's go 6,500 times 0.2. Are you questioning your multiplication?
No.
Yes.
Oh, maybe I am. 2, 13, no?
No, you're fine.
0, 0, 0. It just doesn't seem small enough. Like 2 tenths to me seems like it should be smaller than 6,500.
Okay, so here's one thing you can do. What's 1% of 6,500?
Yeah, see, I knew that. 650.
Okay. So that would be 2, right?
Yeah.
Okay.
So 1% is 1.
So I think what's happening is,
I'm not turning my percents into...
right, Naomi, read the problem again, because does it say 0.2% or 0.2 of 65?
0.2 of 6,000.
So you want 0.2 of 6,500?
Yes.
Is
Okay.
it 0.2%?
That's why I'm asking, because that's going to be a different thing,
Yeah.
right? So that's why what you're doing, you're like, yeah, it seems right, but 2% is less than a percent,
Yes.
right? So just read it exactly as it is on your paper.
Okay. 0.2% of 6,500.
Okay, so I know what I am doing.
Okay.
Okay, so we're going to multiply, And right now it's 0.2, but we have to change it into a percent.
Right, it's not just 0.2 because
we have to move it
0.2%
here.
is going to have more zeros on it.
Yes. So 0.2% is going to have more zeros. Naomi, so we're going to go, we have to change this to a percent, so we have to go this way twice. And so we have to multiply 6,500 by 0.002.
So what you actually did was fine, you just need to move the decimal point now.
Yes, so
Right.
our number here is going to be the same. And now instead of just one decimal, we have to move 3 decimals. And now 13 is 0.2% of 6,500. So when I got this 1,300, I thought, well, that's too big. And so I was thinking something's wrong here. So when we get an answer, we have to check our answer for its reasonableness.
So, right, and I was going to bring that up. So does that make sense, Naomi?
Yes.
Okay, and April, I'm glad that you actually did that and questioned yourself, because that is the importance of estimating and looking reasonably at an answer and then being able to justify it a little bit, just thinking in your head, does that answer even make sense? Because April was able to do it with the times 0.2
But it didn't
and
make
got
sense.
the 1,300, but then she looked at it and was like, well, that's a little odd, right? So being able to estimate and know that it's going to be a small number, that way you can kind of look at it again. And then we went ahead and kept looking, and it's like, oh, 0.2%, we need to move the decimal over a couple more spots.
Which is less
So
than one.
nicely done, Naomi, and for that great problem, you've also got yourself a ticket to the Kern County Fair. So congratulations on that. We hope you have an opportunity to go do that. We do have phone tutors available until 5:30 this afternoon. In studio, we have a 5th grade student from Quailwood. This is Tina in studio with us this afternoon. So Tina, come on back over to the board, young lady. Time to get you back to work. So here is another one of your homework problems. Grace's Catering Company received an order for 118 apple pies. Oh my, this is the season for apple pie too. Do you like apple pie?
Yeah.
I love apple pie. Do you have a favorite? Did you know there are different types of apple pies?
No.
No? April, have you ever heard of different types of apple pies?
Only because there's different types of apples.
Yeah.
And if you use different types of apples in a pie, you'll get a different flavor.
There you go. So they have like Granny Smith apples, where you just use red apples. French apple pie with a different like crust on top, right? Kind of like a crumbly one. I like all of them, no matter what one it is. All right. So Grace uses 8 apples to make 1 apple pie. How many apples does she need to make all 118 pies? All right, girls.
So what do we do, Grace? I mean, Tina, I keep taking the name out there. Tina, what do we do?
Divide.
Divide. So, what are we looking for?
How many apple pies she needs to make in all?
So what do we know? We know that it takes how many apples to make 1 pie?
1 apple. 8 apples.
8 apples. It takes 8 apples to make 1 pie.
Yeah.
Right? And she needs to make 118 pies. Okay, so what happens if we divide? What are we dividing if we divide?
I forgot that.
118.
No.
So,
You want
Keep
me
going.
to stop her?
well, no, you go ahead and put your 8 on the outside like you're going to do. And I just want you to question her
Okay.
as to, before you even start,
Okay.
if this is the right process and why it might or might not be.
Okay, so you're going to divide 118 by 8. So what type of number will you get when you do that? Are you going to get a bigger number or are you going to get a smaller number? In division.
Probably a bigger.
A bigger number? Okay, so when we divide, we're splitting into groups. So we have this amount and we split into an equal amount of groups. So if we have this amount here and we split it into groups, is each group going to be smaller than the original amount or bigger than the original amount?
Smaller.
Smaller. So when I divide, I'm going to get smaller. So if I take 8 apples to make 1 pie, and I need to find out how many apples I need for 118 pies, do we need a smaller number? Because we're going to go 8, 118 times. So each pie takes 8 apples, and we're making 118 pies. So instead of dividing, I should make a larger number.
Multiplication.
Let's multiply. Okay, 8 times 8.
8 times 8 is
64.
60.
And 8 times, okay. 8 times 1 is 8
8.
plus 6 is 14.
And then 8 times 1 is 8, then that's 9.
So does that make sense? So if I said every 1 pie takes 8 apples, and then I do that 118 times, should I get a number like 944?
Yeah.
Does that make more sense?
Yeah.
Should be bigger, not smaller?
Yeah.
Well, you thought that originally, right?
Yeah.
Good job.
Good. So that's another reason you want to think about your answers, right? Because if you need 2 pies, you're going to multiply times 8, 2 times 8. You need 3 pies, 3 times 8. 4 pies, 4 times 8. Well, 118 pies. That might satisfy a few of the folks around here, but everybody will be well fed. We do have phone tutors available until 5:30. We'll be back with more right after this.
This week, Lab TV travels to John F. Kennedy High School in Silver Spring, Maryland, where Navy engineers are helping kids build some very cool underwater vehicles. It's called Sea Perch. Kids learn about engineering, science, and math while they create their own water robots.
It's a Sea Perch. It's called a ROV, a remotely operated vehicle.
Something that scientists will use. It goes underwater.
So it's like what they used to find the Titanic.
Of course, these are not the same underwater robots that the Navy uses, but they operate on the same principles. It starts with building the Sea Perch frame. The kids use PVC pipe.
They gave us long ones and we cut them, but we had to construct the actual structure.
On the first day, we pretty much cut the PVC and put the floaters on. And the second day, we started the motors. And third day, I put the propellers on. And then today, we built the circuit board boxes and we labeled them for if the motors go forward or backward.
To power their Sea Perches, the kids use a battery connected to 3 electric motors. These were potted in wax to make them waterproof. They also wired their own electrical circuits.
It overwhelmed us in the beginning, but when we got all the steps, put it together, and it's pretty easy.
In this electrical circuit, a battery supplies the power. The energy that leaves the battery must return. That's why it has 2 terminals, negative and positive. Negatively charged electrons travel through wires to power a load, like the motors, and then return to the positive terminal. When you flip a toggle switch, the circuit is closed and the motors spin. When it is open, the motors stop.
We had to solder everything on the back.
Here you can see all the soldering things we had to do.
One of them is for making it go down, and one of them is for propelling it up. It was really fun putting it together. I just can't wait to see it go in the water. We just hope it works.
Yeah, that's the biggest goal, make it work.
The kids take their vehicles to the Carderock Naval Lab to try them out. But first, the Sea Perches need to be made neutrally buoyant.
Right, if something is buoyant, that means that it floats. So today you're going to get your Sea Perch to be what's called neutrally buoyant. It's not quite completely floating, and not quite completely sinking.
Buoyancy is the upward force that keeps things floating. It is determined by the weight of an object and the weight of the water that the object displaces.
I'm going to put the weight in the cup of water. It displaced water into my box. So here's how we find out if something is going to float or sink. If I weigh my weight and I weigh the water that it displaced, if the weight of the weight is heavier than the weight of the water, it will sink. The weight of the object is lighter than the water, it will float.
And now for the fun part, some awesome underwater action.
It makes me want to get into engineering when I go to high school, because usually at first I wasn't that interested, and then I found out that we could do stuff like this, so now I'm interested.
And it looks like we have a whole class of future engineers. To find out more about Perch, electrical circuits, and buoyancy, check out labtvonline.org.
All of those team activities are fun activities as well. All right, we've got a few minutes left here on today's program. We've got Tina, a 5th grade student from Quailwood Elementary School. And you first learned about this program when?
A couple minutes ago.
Well, that you were going to be on.
2 years ago.
Yeah, 2 years ago, because your sister was on,
Mm-hmm.
right? And you were off on the side and you were able to
Yeah.
watch her do some work. And you thought that it was pretty cool that she was doing that? So is it still pretty cool?
Yeah.
All right, good. I want to make sure that you're having some fun and you're learning something today too, right?
Yeah.
All right. So you're in 5th grade, and have you worked with decimals at all?
Uh-uh.
Good. So this is going to be a big day for you, because you're going to be working with decimals later on during 5th grade.
Yeah.
And you will be working with decimals, what do you think, April, for the next 10 years in school?
Oh, absolutely.
Easy. For the rest of your life, you're going to be working with decimals.
Did you work with decimals in the 4th grade?
No.
All right. So we've got a problem up there for you. And you and April are going to work your way through this problem. But I'd like you to start and think about how you would solve this problem if there's another way to write it, and it might make it easier. All right? So girls, take it away.
Okay, so we've got 12 and 9/10 plus 10 and 21 thousandths. So if this is called horizontal because it goes from left to right.
Yeah.
So do you think you can write it in a different way that might make it easier to add?
Probably like one on top and one on bottom.
Okay, so let's try to write it vertically. Go ahead and take a stab at it. How do you think we should write these two numbers? Why'd you choose that one first?
Because it's bigger.
Okay. It's got more digits, for
Yeah.
sure.
I was going to say, why is it bigger?
Okay, so, and why did you write your second number right there?
Because it has less digits.
Because it has less digits. Thank you for using my word. So now I have a question for you. Each digit has a value. Can you tell me the value of 1 in each of those problems, or each of those numbers?
9 ones.
So this is 9 ones?
Yeah.
Okay, so my question to you is, I just noticed there's one here, but this one and this one, what value do they have? So if you were to think about how much this one is worth and how much this one is worth, what value does that one have?
I'd say that this one would be in the 10,000s.
Okay.
And then this one in the hundreds.
Okay, so write for me 10. And then write for me 12.
Underneath?
Yeah. So now I'm going to ask you the same question. What's the value of this one and what's the value of this one?
10.
10. Okay. So if I look here again, if the value of this is 10 and the value of this is 10, how about you look over here and see if there's a relationship between these numbers and these numbers?
Mm-hmm.
What do you see?
They're both before the decimal.
Yes, so they're both before the decimal. And if this is 10, what's the value of this number right here? This is
Ones.
This is your ones, and then this is your tens, you told me that, which would make this your tens, and this is your ones. So those are the same place value, right?
Yeah.
So when I add decimals, I have to keep my place values together. Okay, so if this is the tens and this is the ones, decimals go backwards, so then this becomes tenth. This is the tenth, hundredth, thousands. So remember when I said to you, this is 10 and 21 thousandths? It's because it's 10 and then this decimal has a value, okay? So using this 10 and this 12, rewrite the numbers vertically. That's horizontally.
Oh.
So rewrite these numbers the way they would go right here. So use this 10, use this 12, and rewrite these numbers.
These two?
Yes, but rewrite them right here. Write them again. What were you thinking about just then? You paused a little bit. Why did you pause?
Because I didn't see the one at first.
And in your mind, this number is bigger because it has more digits in it, right?
Yeah.
But is the value really bigger?
No.
No, because it has more digits, but the value isn't bigger because this is 10 and this is 12 and. So which of these two numbers are really larger? Have more value?
This one.
Yeah, because it's 12,
Yeah.
right? Okay, so when I add decimals, I have to remember to put all the place values together. This is tens, the tens place. This is the ones place. Tenth, hundred, thousand. So since everything's lined up, I can just add straight down. So go ahead and for every space, put a 0 here and a 0 here, and then just add, like right after the 9, put a 0 and then another 0 and add straight down. So why'd you put the decimal here?
Because the decimal and there's another decimal.
Absolutely. Good job, Tina. And your answer is 22 and 921 thousandths.
There you go, nicely done. So for your first time dealing with decimals, that's an important thing because when you add and subtract decimals, you need to line up the decimals. All right, does that make sense a little bit?
Yeah.
Good. So I've got two questions for you. Did you learn a little something today?
Yeah.
Do you feel as though your brain got bigger?
Yeah.
Good. Did you have fun?
Yes.
That's the key right there. All right, we do have phone tutors available until 5:30 as we do most Tuesdays and Wednesdays throughout the regular school year. Thank you to Katie Wardell and the Ford Dimension and bringing Iman in, a senior from Bakersfield Christian High School today. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.